This is our first review lecture for equilibrium, which is the very first thing we looked at this year, or otherwise known as dynamics is the formal name. And so I'm going to start off with Newton's three laws, and to try to help you remember what they are, we're going to do the Dr. Seuss or Dr. A version of Newton's laws. And so we're going to call them thing 1, thing 2, thing 3, instead of Newton 1, Newton 2, Newton 3. So that might help you remember. So, thing 1, things exist. Well, if things exist, they can only exist if they are made of matter. And one of the criteria of matter is that it has to have mass, and mass is a measure of inertia. So, you can remember Newton's first law, thing 1, first law of motion is the law of inertia. And what that means is that a quality of matter is that it maintains its motion, and we have to qualify that in the absence of a force external to the system. So anything with mass maintains its motion because of inertia, unless it is acted on by an outside force. But let's just remember, things exist, law of inertia, things maintain their motion. So, more formal way of thinking about it, I'm still on thing 1 here, is that inertia is the characteristic of maintaining motion. And maintaining motion means it's either at rest or moving in a straight line at constant velocity. So when we're talking about maintaining motion or retaining its motion, either it's not moving or straight line motion at constant velocity. So that is thing 1. Things exist. Thing 1, things exist. Thing 2, things change their motion. The amount of inertia or mass affects how much change in motion. Okay, so thing 2, things change their motion. The amount of inertia or mass affects the change in motion. And the other thing that affects the change in motion is the size of the external force. And external force would be external to the thing 1. Okay, so thing 1, things exist. Thing 2, they change their motion. So again, we can formalize that. I did not know I was going to be doing this. Okay, so I know this is awkward, so I'm going to rewrite it. So thing 2, what it really means is that the net force acting on the thing divided by the mass of the thing is equal to the acceleration of the object. Now, so that is how you find acceleration. The definition of acceleration is that it is the rate of change of velocity. And remember, this change in motion. This change in motion can be change in speed and or direction. Okay, so thing 1, things exist. Thing 2, things change their motion. Thing 3, you need 2 things to change the motion. You need a feeler and a dealer. The interaction between the feeler and the dealer is equal and opposite. Okay, so it's kind of funny. We've got thing 1, things exist. Thing 2, things change motion. Thing 3, you need 2 things. Okay, 2 things to change the motion, or 2 objects, a feeler and a dealer. So this is the idea. You need 2 objects to change the motion, a feeler and a dealer. So we need to visualize these laws so that they are useful, because just Newton 1, 2, 3, it's like, whatever, who cares? And so the way that we visualize the laws, law 1 and law 3, we use a system schema. So the bubbles visualize law 1, and system schema is the bubble diagram. So the bubbles visualize law 1, inertia or things exist. The lines between the bubbles visualize law 3. The interactions between objects or systems are equal. Oh, missing a parentheses. So laws 1 and 3 are visualized with the system schema, law 2 with the free body diagram. So we're going to try this. Person pulling a rope which is attached to a wagon of mass M with a box of mass M on the sled. Okay, so for this video, I'm just going to do the system schema and the free body diagram. So the first thing we're going to do is draw a picture. We've got a surface, we've got a sled, and we've got a box on the sled. Box has little m, the sled is big M, there's a rope, there's an angle theta, and then, oh my gosh, that's going to be a big person. Big person pulling the sled. Schema. We've got a person. We've got the box, the sled, the rope. I'm going to do the surface, but you can do surface and earth together, but you've got to have earth. So let's think about the interactions. Everything is connected to the earth. I'm going to do that in gray just because otherwise it gets messy. So all of those force due to gravity. Okay, between the person and the rope, there's tension. Between the rope and the sled, there is tension. Between the box and the sled, there is friction. And between the sled and the surface, I have normal force. And I'm also going to put in friction, because I did not say it was frictionless. And all the gray ones are the force due to gravity, also known as weight. And the formula for the weight or force due to gravity is mg. So that is our schema. We need to do a free body diagram, but in order to do a free body diagram, we need to know which object we're talking about. So we don't do a free body diagram, or it's impossible to do a free body diagram for the entire schema. A free body diagram is visualizes the net force acting on a single object. So for number 1, it asks about the sled, and so that is what I'm going to do is the sled. So free body diagram for the sled. Dot represents the sled. Okay, I'm going to take these one by one. So there's a force of friction. I'm going to start right here. There's a force of friction between the sled and the box. And that is actually going to the right. And the way I can tell that is that if I jerked the sled out from underneath the box would go to the left. So the force of friction, which means that force of friction opposes the slide. The box would slide left. And so that means, I think my arrow is wrong. So that means that the force of friction on the box by the sled would have to go this way, because it would oppose the direction of the slide. And so that means, if I'm looking at the forces on the sled, force of friction on the sled by the box has to be the opposite direction, because that's what Newton's third law tells us, equal and opposite direction. Okay, let's do normal force. That's easy. So we've got normal force on the sled by the surface. And then we've got force of gravity. Remember, this is weight on the sled by the earth. We also have a force of friction. Force of friction on the sled by the surface. Now the slide of the sled is to the right. Let's do that in green. So sled is sliding this way. So the force due to friction on the sled by the surface has to oppose the slide, so it's going to the left. And then the last one, so we've got 1, 2, 3, 4. Last one is the tension. It's going at an angle. So we've got tension on the sled by the rope. I have no congruency marks, but that is my free body diagram.